Yeah, can you hear me now? I think I'm going to start the class now. This is the trigonometric functions I'm going to explain. In trigonometric functions, mainly the 11th standard syllabus, NCERT syllabus, I'm going to explain in all the problems. Any doubt you have, you can ask me in the chat box. You can ask me. I will clarify that. Now, the topic in trigonometric functions. So the topic is trigonometric functions. So this is the topic trigonometric functions. Basically, in trigonometric functions, when you're learning the trigonometric functions, always you can remember. So when they're teaching the trigonometric functions, so generally in the trigonometric function you can see here. I can be able to see this the board right. I think this is the topic in trigonometric functions. First of all, we have total 6 functions we have. So the 6 functions, see here the 6 functions we can observe here. Whatever the 6 functions I'm saying here in trigonometry, sin x, cos x, tan x, reciprocal of these three, you can write cosecant x, and here cos x is secant x and cot x. These are the 6 mainly trigonometric functions we have. Here I am going to discuss about the trigonometric functions. I am going to solely about mainly these are the 6 trigonometric functions. How they defined here? How they define the sin x they define. So here you are considering these are the angles in radians. Because angle we know generally we measure angles in radians and degrees. Here I am discussing trigonometric functions because you are familiar with how to convert radians degrees and radians. I have taken here sin x. I have taken how they define the sin x. Suppose if we take this is the x here. So they define sin x is equal, let it be this is ABC is a triangle. So the sin x, I can define opposite side by hypotenuse, I can write AB by AC, I can write sin x. Again they define, this is the sin x. Cos x they define, cos x extends side by, or something they may use base, I can write BC by, I can write AC. Same time tan x. If I take tan x is equal to the opposite side by adjacent side, AB by BC. Some people they may use perpendicular by base. They define like this. They define like this. Remember, these are the definition of sin, cos, tan. If you take reciprocal of this, cos x. So you take cosecant x. Reciprocal of sin is cosecant x. This we can define AC by AB. AC by AB. Cosecant x is AC by AB. Now I can define this one secant x. So what about secant x? I can define AC by BC. AC by BC. And reciprocal of tan x, cot x. I can define cot x is equal to BC by AB. Now you can observe one is the reciprocal of the other. If you multiply these two, it gives 1. Sin x into cosecant x is 1. You can observe your sin x into cosecant x is equal to 1. The product is equal to 1. Simply cos x into secant x is equal to 1. And I can write tan x into cot x is equal to 1. The product is equal to 1. One is the reciprocal of the other. When the product is 1, one is the reciprocal of the other. I can write sin x equal to 1 by cosecant x, cos x equal to 1 by secant x, tan x 1 by cot x. Like reverse. Cosecant x is 1 by sin x, secant x 1 by cos x, cot x 1 by tan x. We can write. One is the reciprocal to the other. Here we can learn the maximum value, minimum value of sin x, cos x, tan x. Like here, I'm talking about the range. Domain also I can discuss it later. In the beginning, you can think about what are the value of x, what are the values, maximum value of sin x, what are the maximum value of cos x, tan x. We can think. Generally, when you're comparing with that, to find out the domain in range, so you can think. And I've taken these 6 functions. You can observe here. So these are the functions I defined here. I have written like this. So always remember the sin x value, AB by BC. In a triangle, AB is less than AC, right? AC is the hypotenuse here. You can think always AB is less than AC, right? AB is less than AC. What are the lengths positive values? AB by AC less than 1. So what about this is sin x, right? Sin x value less than 1. When the case, well, you can see here, When AB equal to AC, when do you get AB equal to AC? When it is 90 degrees, AB will become AC, then sin x will be less than or equal to 1. So max value of sin x is 1, left of 1, it not be more than 1. So you can think about that. If I take like this, so I can think this is the ray. I can consider this is OA, OB, I can consider like this. This is theta. You can see here, suppose this is the ray, I can take it x comma y. So this is x, this is y, this is r. For example, you write sin x here. If I write sin x is equal to, just if you think, when I have written sin x is equal to opposite side by y by r never be 0, it's a positive value, depend y value. Suppose if the theta, it comes here, if theta is for 90 degrees, then the b will come here, correct? Then the b will come. So then automatically b will come here. What you observe here, r is equal to y. When r is equal, you can see when 90 degrees, sin 90 degrees. So if you take sin 90 degrees, then y is equal to r, then we will get r by r is equal to 1. Sin 90 is equal to 1. When it is 90 degrees, this OB, this ray comes here, automatically y equal to r, then what will be x value will be 0. When x value will be 0. When it comes here, you know that you take the point here, automatically this point will become 0 comma y. Only y will exist, right? It will be 0 comma y will exist. So automatically what you will think about that? When this is 0 comma y will, we can see here x will be 0 here. So sin 90 is, or sin 90 is 1. So max value of sin 90 is 1. Otherwise less than 1 due to this is a proper fraction. Correct? It is a proper fraction, it is less than 1. In the case of 0 to 90, it will come. If we take in the case of this angle, if we come minus pi by 2, this is pi by 2, right? If we come this side, towards this side, this angle will come minus 1 less than or equal to sin x less than or equal to 1. So when you get sin value 0, when OB coincides with OA, here you will get x comma 0, y will be 0, 0 by something 0. So that is the reason here, in this case you will get 0 also will be the sin 0, 0. So here sin x lies between minus 1 and 1 always. Why? Because the value of sin x is AB by h, the fraction is proper fraction. When positive angle 0 to 1 it will come, negative angle minus 1 to 0. Same way think about cos x. This is also proper fraction. So this value also similar to that. This BC by AC. You know that BC is, you can compare this BC value less than AC. BC by AC less than AC. But when here you can see here, when OB coincides with cos 0. If we come here, OB coincides with OA, angle is 0 degrees at that time. At that time 0 means here what will be this y value will be 0. Why? Because if we define here, in this triangle if we define, what about cos x, cos theta, otherwise you think cos theta. If I define cos theta, it will be x by r. X by r, you will get x by r, right? You will get x by r. You will get cos theta, you will get x by r. So you will get x by r here, x equal to r equal to x. When 0 degrees, cos 0 if we take, cos 0 equal to x by x. It comes 1, cos 0 is 1. So max value of cos x is 1. Similarly, I can define. So because the fraction is proper fraction. If these two are equal, in that case cos 0. When angle is 0, BC equal to AC, then automatically you will get cos 0 is 1. So I can define even cos x value lies between minus 1 and plus 1 I can define. So maximum value of sin x is 1, minimum value is minus 1. Max value of cos x is 1, minimum value is minus 1. You can think about that. We can decide maximum and minimum value. At the same time, here you think about tan x is equal to AB by BC. When I have taken tan x is equal to AB by BC, you can think I have written AB by BC. So here you can see in a triangle, the problem is sometimes AB, when I have taken this is AB by BC. So AB greater than BC, or I can get AB less than BC. So both options I will get, both possibilities are there. If AB greater than BC, it's improper fraction. If AB less than BC, it's a proper fraction. So sometimes it will be proper, sometimes it will be improper. Proper means between 0 to 1. Improper means more than 1. So finally, it gives a real number. So this entire tan x belongs to R. It gives a real number. The value of tan x is a real number. So no maximum, no minimum in the case of tan x. We can't find no maximum, no minimum. We can't find that. So that's the reason I can write minus infinity less than tan x less than infinity. Tan x lies between minus infinity and infinity always. The tan value lies between these two values, tan x value. Even if you think about understood here, finally what I have done here, I explained the maximum value of sin x is 1, minimum is -1. For the case of cos x, maximum is 1, minimum is -1. In the case of tan x, no maximum, no minimum. So you just observe here, -1 less than or equal to sin x less than or equal to 1, -1 less than or equal to cos x less than or equal to 1, minus infinity less than tan x less than infinity. Tan x lies between these two values. Just remember, tan x lies between these two values. It lies between these two values will maximum, no minimum. Same thing you think about cosecant x. What about cosecant x? So if sin x you have taken, sin x you have taken between -1 to 1. You take any number between these two. You take reciprocal. Suppose for 0. If you take reciprocal of 0, it goes to infinity. Approaching to 0 plus infinity. Approaching to 0 from left, it goes to minus infinity. But here you can see, if you take any number 0 to 1, for example 1 by 2, reciprocal is 2, you will get more than this. You take any number reciprocal, you will get more than, you will get this one more than this. So this is in the case of cosecant x, because this is sin x, this value is cosecant x, this is cosecant x. So the value of cosecant x is left of -1 or more than 1, it will come. So sin x lies between -1 and 1. Cosecant x is more than 1, left of -1. Same way you can think this is the value of cos x. So including 1 with both, here I can write this is secant x, this is secant x. I can write secant x. I can express like this. That means you can see cosecant x value less than or equal to -1 or cosecant x value greater than or equal to 1 above that. Similarly, if you take reciprocal of this also, secant x less than or equal to -1 or secant x greater than or equal to 1. I can define minimum value, maximum value. In the case of sin and cos, there is no maximum, there is no minimum. In the case of secant and cosecant, we can't define. Less than up to in minus infinity plus infinity. We can't define for cosecant, secant, no maximum, no minimum. We can define only in the case of sin and cos, only maximum and minimum. But here in the case of tan, if you take reciprocal, same thing it will come minus infinity less than cot x less than infinity. So cot x also lies between minus infinity plus infinity. No maximum, no minimum. So these are the range of the trigonometric function, like each one. I have discussed about range. Sin -1 to 1, cos -1 to 1, tan minus infinity plus infinity. These are the reciprocal of sin. Cosecant x less than or equal to -1. Cosecant r greater than or equal to 1. Secant is less than or equal to -1 or greater than or equal to 1. So this is related to even cot x minus infinity to plus infinity. So these are the range of the 6 trigonometric functions. Here, what about the domain of each trigonometric function? So there is no restriction here. So before that you can think, I will think about if you take anything here. For example, if you take sin, I can think about, suppose for example, I am discussing sin theta equal to the value of sin theta. When 0 here, this will be sin theta equal to 0. When I am talking about this one, for example, I have taken like this is theta. So I have taken, this is OAP, I have taken this one. So this is the point x comma y, this is our x and y. When I have taken sin 0. So when I am talking sin theta equal to 0 means B will come here. So it will B will come here. Automatically, what will happen here? This point will become here x comma 0. Y should be 0 on x-axis x comma 0. But if I define here what is sin theta actually, sin theta let y by r. So since y is 0, 0 by r, it comes 0, right? Sin theta will be 0. That I can define here. But you can observe here, I can rotate any angle here. There is no restriction here. I can take any angle here. Sin theta I can define for any angle. So they are telling here no restriction for that. Here define only sin theta, sin 90 also I can define here. When sin 90 is equal to 1, we proved that. So what I am going to explain here, when I am taking these values for what is the domain of sin theta, no restriction. I can take any value. You think about sin theta. So what is the domain of this function? So when I am talking domain of this, when I am talking particularly domain of this function, when I am talking sin theta, this is r. No restriction here. Theta can take any real number. Any real number. Even cos theta, any real number I can consider. Whereas sin, cos, tan theta. If we count tan theta, what is the tan theta actually? Tan theta is sin theta by cos theta, right? So cos theta should not be 0. To define this function, cos theta should not be 0, right? When cos theta not equal to 0, then only I can define tan theta. But for every odd multiple of pi by 2, cos will be 0. That we know that, right? For every odd multiple of pi by 2, cos of 2n plus 1 pi by 2, cos will be 0. For every odd multiple of pi by 2. Why, sir? For this angle, the terminal ray coincides with y-axis. See here, when I'm talking about terminal ray, this is the terminal ray. If it comes here, if this angle is pi by 2, suppose this is the terminal ray here. I have written here, suppose this is B. So this is B here. Suppose after coming to pi by 2, the terminal will be here, 90 degrees. After the terminal will come here, 3 pi by 2. So 3 pi by 2 will come. Whenever the terminal ray coincides with positive y-axis, when I define, you can see, when I'm defining this, you can think these are taken as theta. So when I take this is x, this is y, this is r. So this is x comma y. You think what is cos theta here? If you take cos theta is equal to y by, you can write x by cos theta equal to x by r. Correct? Cos theta equal, you can write cos theta equal, you can write here x by r. X by r. You can think here, when I have written here, so whenever the terminal coincides with y-axis, then angle will be 90, or you can see, if it coincides with positive y-axis, angle is 90. If it coincides with negative y-axis, 3 pi by 2. After that, you can come here, again it will come, you can see 3 pi by 2, 2 pi plus pi by 2, 5 pi by 2. It comes 5 pi by 2. Pi by, this is pi by 2, also same position. Pi by 2, 3 pi by 2, 5 pi by 2. Every odd multiple numbers you can see pi by 2, 3 pi by 2, 5 pi by 2. Every odd multiple of pi by 2, cos will be 0. The terminal coincides with y-axis. When the terminal coincides with y-axis, x value should be 0. So 0 by something 0, cos will be 0. So that the cos of 2n plus 1 pi by 2 is 0. To define tan theta, the denominator should not be 0. To define tan theta, the denominator should not be 0. So the denominator should not be 0. Cos theta should not be 0. So since cos theta should not be 0, so that is when only tan theta exists. So that means here, when you're talking about domain of this, I should remove 2r minus 2n plus 1 pi by 2, n belongs to y. I should remove this. I should remove this, right? When you're talking about this, I should remove this from this. When you're talking about the domain of tan theta, I should remove y, because at these values cos will be 0. I can consider this 2n plus 1 pi by 2, n belongs to y. I should consider this restriction when I've taken this one. So here I can think about this one. This is the domain. I'm talking about the range of this. So range we discussed, this is minus 1 to 1, right? I have this one, and this entire value will be minus 1 to 1. And r close interval I can write sin theta value I'm talking about minus 1 to 1. I can write this is minus 1 to 1. This one, tan theta is a real number, range is a real number. Minus infinity to plus infinity, I can also express. Minus plus infinity, I can also express. This way I can express. This is domain and range. I've written this mainly 6 functions I've written here. So you can think about when I'm talking about the domain and range, sine, cos, tan. When I've taken like this. So if I define, this is the reciprocal cosec theta. So cosec theta. So r minus, what is the restriction here? I should think about the restriction. But we know cosec theta value. I can think about cosec theta value. Cosec theta less than or equal to minus 1, or cosec theta greater than or equal to 1. That we know that. But here you can think, sir, sin theta is, cosec theta is 1 by sin theta. So sin theta should not be 0. Sin theta should not be 0, right? But for every multiple of m pi, sin will be 0. Why the reason? For every multiple of pi, if you take every multiple of pi, so 0, pi, 2 pi, 3 pi, so thus it will come, angle will be on the terminal coincides with x-axis. When it coincides with x-axis, y should be 0. Automatically the sin value will be 0. So for every multiple of pi, 0, 2 pi, 5, 3 pi, 4 pi, 5 pi, for every multiple of pi, sin will be 0. So that is the reason cosec theta should define when sin theta should not be equal to 0. So I can define r minus n pi, n belongs to y. So this is the expression for cosec theta. So I can define this one. Coming to sine, cos, tan, cosec, reciprocal of cos, secant theta. When I'm defining secant theta, secant is 1 by cos theta, right? Same condition, 1 by cos theta, even tan, sin by cos. So cos theta should not be equal to 0. So you will get r minus set of 2n plus 1 pi by 2, n belongs to y. I can write like this. Same way, I can also define here secant theta less than or equal to minus 1, or secant theta greater than or equal to 1. Same way you will get that. So after the final one, I can discuss about sine, cos, tan. I can discuss now. This is the values. Because next one, reciprocal of tan, cot theta. So cot theta also same. What is cot theta? Sine by cos. So this is, you can see, this is sine theta by cos theta. This is cos theta by sine theta, right? So sine theta should not be 0. So sine theta equal to should not be in this case same thing. So 1 by sine theta, 1 by sine theta should not be 0 to define cot theta. So same thing r minus n pi, n belongs to y. Again it's a real number, minus infinity to plus infinity. This is like domain and range of the 6 trigonometric functions. Now, after learning this, you can see just one, we discussed about the only all the domain and range we learned now. After learning the domain and range, now I'll discuss about co-terminal angle. What is the meaning of co-terminal angle? So if you consider co-terminal angle, the co-terminal angle, it will be considered as, like you can see, if two angles are the same terminal side, those two angles are called co-terminal angles. What it means actually, you can see here, when I'm taking here, for example, you can see here, this is theta. So you can complete one, again you will come back this. After completing one complete rotation, it takes an angle of 2 pi radians. So this is theta, this will become 2 pi plus theta. Again you can come back again here. If we combine like this, it become, this angle will be, you will get 2 into 2 pi plus theta. You will get, you are continuing this, like one more rotation you have done. This is 1 into 2 pi, 2 into 2 pi plus theta. It will come here. If two angles are the same terminal side, those two angles are called co-terminal angles. In the case of co-terminal angles, observe here. In the case of co-terminal angles, so two angles are co-terminal, right? So the value should be same. The value should be same. That means I can think sine 2n pi plus theta, which is equal to sine theta always. Sine of 2n pi plus theta will be equal to sine theta. So number of rotations, how many number you take? N is the number of rotations. So generally we will write our convenient like this. This is n into 2 pi plus theta, sine theta. That meaning is sine theta, n into 2 pi. So I will write. So you remember in your mind, 2n pi plus theta comma theta. N is an integer. So I can take n is an integer. These two angles are called co-terminal angles. If two angles are the same terminal side, those angles are called co-terminal angles. For example, value of sine 30. So for example, I'm telling sine 30, the value of sine 30 degrees 1 by 2. After completing one rotation, we come back here, 360 plus 30, sine 390 also 1 by 2. So any trigonometric function, if two angles are the same terminal side, those values should be same. These angles are co-terminal angles. Sine 390 also 1 by 2. Complete two rotations. It will come 7. So you will get 360, 720 plus 750. Even sine 750 will become 1 by 2. So I can say these angles are called co-terminal angles. Just understand this is angles are called co-terminal angles. Now after learning co-terminal angles, now you take any 6 trigonometric functions. So because there is no change here. So the value will be same, means you can remember now. I can discuss about, you can see here, sine of 2n pi plus theta will be sine theta, cos of 2n pi plus theta will be cos theta, tan of 2n pi plus theta will be tan theta. Because there is no change, value will be same. Because these two angles are co-terminal. So even I can write sine cos tan, cosecant of 2n pi plus theta will be cosec theta. And I can write here secant of 2n pi plus theta will be secant theta, and I can write this cosec secant and cot of 2n pi plus theta equal to cot theta. These values will be same. That just to remember, these values always will be same, right? Don't forget about these values because co-terminal angles. So the better is to solve the problem, preferably use co-terminal angle concept. Then easy to solve that. Sometimes the angle is in between somewhere, but preferably co-terminal is helps for you. I'm going to solve the problems related to that. In another 10-15 minutes, I will solve the problems. So this is the, just remember co-terminal angle. After that, I am going to discuss about the each trigonometric function. How can you decide about whether positive or negative in each quadrant? Total we have 4 quadrants, right? Again, before that also you can think the position of the angles. Even you can think about the position of the angles. When you're talking about the position of the angles, you can see this when I've taken here. So this is 0. This is, you can write, this is 90 degrees. 90 degrees or pi by 2 I can write. This is pi by 2 also I can write. So this is 0 radian. Everything 0 degrees means 0 radians I can write. Now this is x which is 90, 180 degrees. So I can write pi radians. This is 3. I can write this one 90 and we get 270 degrees, right? This is 270 degrees. I can write 3 pi by 2 radians is also equal to 2 pi. Correct? Complete one rotation. 360 degrees. I can write 360. Everything is coming here. 360 degrees is nothing but 2 pi radians. I can express. So we have 4 quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. Right? Total we have 4 quadrants. In 4 quadrants, let it be, suppose here, if little angle if you subtract 0 to 90, you know that angle is called, you can write acute here. Suppose 90 degrees minus theta. This always becomes first quadrant. If you remove little angle, if you remove from that 90 minus theta, if you add some angle with this 90 plus theta, even again pi by 2 minus theta, pi by 2 plus theta, this will become 180 degrees minus theta. Here it will come 180 degrees plus theta, adding some angle, right? 270 degrees minus theta, and this one 270 degrees plus theta, 360 degrees minus theta, here 360 degrees plus theta. So these are the position of the angles in our 4 quadrants. Right, these are the position of the angles you can consider here. Just these are the position of the angles. I can consider this position of the angles, right? 90 minus 90 plus 180 minus 180 plus theta, 270 minus theta, 270 plus theta, 360 minus theta. Just our written position of the angles are written. Now I am going to explain how do you find all functions for this. I'll get an idea about that. How do you decide what is sin 90 minus theta? What is cos 90 minus theta? How to find cos of 90 plus theta? Sin of 180 minus theta. That I will discuss. This is the position of the angles. Of learning the position, before learning this, before learning the these angles, you should know in which quadrant which is positive. All 6 trigonometric functions. Just you remember the position of the angle. Just you remember. Here, what I am going to explain here. You can see when I have taken this one. When I have taken this one, when I have taken here, you can see here. So suppose for example, I have taken this one. This is first quadrant. I can also say plus plus. So this is second quadrant. I can also say here minus plus, right? I can say minus plus, and this I can say third quadrant. It will be minus minus. And this will be fourth quadrant. I can say here this is plus minus. Cut. This is the position of this one plus minus. The values will be like that. So when I have taken this is theta. So you can think this is x, this is y, so this is r. I can take this point is x comma y. X comma. Just I am going to explain how to decide the values of each quadrant which are positive or negative. So here, after that I will come back to this again. So what I am saying here, so when you are learning this, you can see here, when I have taken this, in this case, you know that sine theta. If you take the value of sine theta, so you will get sine theta is equal to y by r. Cos theta is equal to x by r. Tan theta is equal to y by x. All are positive. In first quadrant, x and y positive. X positive, y positive, r positive. The ratio is positive. So this is positive, 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 right? Even reciprocal functions are positive. So when the angle theta, if theta lies between 0 to pi by 2, if it lies between 0 to pi by 2, in between, if theta lies between 0 to pi by 2, all 6 trigonometric functions values are positive. The values of 6 trigonometric functions are positive between 0 to pi by 2, no doubt in that. All are positive. Why? Because x is positive, y positive, r positive. You take all these 3 positive, reciprocals also positive. So this is the reason here. You can think, you remember here, all 6 trigonometric functions are positive. Always I will consider this is the quadrant belongs to everyone. I can generalize say this is house of all 6 functions. House of all 6 functions. House is supposed to enter my house. I won't take any permission. So I will enter directly. But there is the reason 6 functions can stay here. Their house is a positive. Now coming to here. Suppose if you think about here. Suppose I am talking about theta here. So this is r. And again this is x, this is y. But I know here x is negative, right? X is negative, y is positive. Because we know that here x is negative, y is positive, right? That we know that. Suppose if we take sine theta here, think about in this case. What about sine theta? If you think about, if you take sine theta here, the value of sine theta. If you take the value of sine theta here, so if it is sine theta, you can observe here the value of sine theta. So sine theta will become here, will get y by r. So y by r. You can see I written sine theta equal to y by r. When I written y by r, y is positive, r is positive. So sine theta is positive here, right? If we take cos theta, so what is cos theta here? Cos theta is x by r. So cos theta x by, but we know that x is negative. So this entire value is negative, right? Cos theta is negative. I'm talking about the second quadrant. Cos theta is negative. In second quadrant, if you take tan theta, right? I'm talking about, you can see here. Suppose we know that. Here I'm talking about this one. Here if you take it tan theta. What about tan theta here? If you take about tan theta, so tan theta equal to, you will get y by x. Again, y positive, x negative, the value is negative. So in second quadrant, only sine positive. What about reciprocal of sine, cosec also positive. Here cosec also positive, right? In second quadrant, sine and cosec are positive, remaining functions are negative. So this is house of sine and cosec. Remember house of sine and cosec. This is house of everyone. So you remember all. They use all here, all, everyone. All are positive. I can repeat all are positive here. So sine and cosec, this is house of sine and cosec. Let it be yes. Just to notation. Sine and cosec are positive. House of sine and cosec, their house. Positive, no need to ask anyone. Other functions to enter in this, they should request. Those functions are negative there. Those are negative here. Sine. If we come here, now you can see x and y. Y also, this is r also is positive. See here, is both are x and y are negative here. X and y are negative. So in this quadrant, if you think here, what about here? Sin x is equal to, you will get y by r. Y is negative. This value is negative. If you take cos x, right? Is negative. If we take cos x will be, you will get x by r. Again, x is negative. This value will get negative. If we take tan x, so y by x, negative by negative is positive. So this value is positive. So in third quadrant, this is third quadrant, right? In third quadrant, only we can find it sine, cos, negative, tan x is positive. So reciprocal of tan x is cot x. So in third quadrant, we can say tan x and cot x are positive. Remaining functions are negative. So remember, this is house of tan and cot. Just remember, T is the symbol for this. Third quadrant symbol for T. T represents the functions of tan and cot are positive in third quadrant. Now coming to here, if we think about this one. So when I'm thinking about this one here, when I'm talking about this is x, this is y, this is r. You think here, you will write sine theta is equal to y by r, cos theta is equal to x by r, and tan theta is equal to, you'll get y by x. If we consider like this, so you can see here, this is y is negative, so this is negative, and cos theta x, this is positive, y by x, y you can see x is positive, y is negative, so this is negative, only cos is positive. In fourth quadrant, only cos is positive. Here along with secant, reciprocal, secant also positive. So this is house of cos and sec. So other function to enter their house, they should request, so those functions are negative. So only here, you can remember now, in this fourth quadrant, I can observe here, only you can see here, cos theta is positive and also secant theta. The remaining two functions are negative. Just remember that. Other two functions are negative. Now, when I'm taking after discussion of this, you remember now, all silver teacups. Like you can remember any one phrase to remember. All functions are positive in first quadrant. Here, sine and cosec are positive. Third quadrant, tan and cot are positive. In fourth quadrant, cos and sec are positive. So you remember like that. First quadrant is house of everyone. All are positive. Second quadrant is house of sine and cosec. Only those two are positive. Remaining functions are negative. Third quadrant, tan and cot are positive. Remaining four functions are negative. In fourth quadrant, cos and sec are positive, remaining functions are negative. That keep in our mind. That you remember that. Now, after learning this, or remember all silver teacups. You can take it. All students take coffee, something. Phrase you remember to remember that. After learning this, even I am going to discuss about what about like trigonometric functions of minus theta. So this is also important concept. trigonometric functions of minus theta. When I'm talking about trigonometric functions of minus theta, so you generally sine of minus theta is minus sine theta. Cos of minus theta is cos theta. I'll tell you this, tan of minus theta is minus tan theta. Even I can discuss similarly remaining other three also. Generally, these two are called. These two functions are called. They will say this is a odd function. They will say functions are odd function, and this function they will say even function. So cos and sec are even function in trigonometry. Cos of minus theta, cos theta, even function. Secant of minus theta, secant, even function. Sine of minus theta, minus sine theta. Tan of minus theta, minus tan theta, odd functions. The reason. So here I will define you what is even function, what is odd function. I can define you. So these are, remember, these two functions are always remember odd functions, and this is our even function, reciprocal. Now how do you get this one actually? Now I will discuss about. I will tell you what is even, what is odd. I can explain that. The reason I explain why they're saying odd, why they're saying even I can say that. But you can see now when I'm talking about this one, even and odd function, you can see. When I'm observing this one, you can see here, this I have taken here. Just this is theta, positive angle, this is minus theta. Just you remember this is minus theta. So you take x comma y. This is the point is x comma y. You can consider the point is x comma y. At this point is I get at x comma y. But here y is negative here. You remember y less than 0. X is positive, y positive. If we take sin theta here, what is sin theta? It will come here. You think what about sin theta value? This is, you can see this is x, this is y, this is r. Here y and this is x, this is r. Sin theta is equal to y by r. Clearly positive. But if we come here, sin of minus theta we compare. Minus theta is you'll get minus y by r. Because the reason y is negative. Minus y by r. Compare these two. So minus sin theta it will come. So sin of minus theta. Sin of minus will be minus sin theta. So sin of minus theta will be minus sin theta, it will come. Sin of minus theta will be minus sin theta. You could take cos theta here. So what about cos theta here? You think about cos theta, x by r, positive. You take cos of minus theta. Cos of minus theta, it will come here, x by r only. Positive it will come, which is equal to cos theta. So you see here, cos of minus theta, cos theta. Same if you compare that. Sin of minus theta minus sin theta, cos of minus theta, cos theta. The same if we think about tan, if we take tan theta, so tan theta is y by x, positive. But if we take tan of minus theta, so if we take tan of minus theta, you get y by x minus y by x, because y is negative, you will get minus tan theta. So like that you will get, so finally you will add here, sin of minus sin theta will be minus sin theta. Similarly, cosecant of minus theta minus cosec theta, tan of minus theta minus tan theta, cot of minus theta, you get minus cot theta. These four are odd functions. I will tell you the reason, I will explain. These are odd functions. So cos of minus theta, cos theta, and the secant of minus theta, secant theta, these two are even functions. Even functions. When they define even and odd function, what is the actual meaning of even function? F of minus x is equal to f of x. If you replace x with minus x, there is no change. These functions are called even function. The meaning I can consider f of minus theta equal to f of theta. In the case of angle, even I can express like this, or I can write f of minus theta equal to f of theta. When these two are same, I can say even function. Even function I can say. That's the definition of even function. I can say that is a even function. I can see here f of minus theta equal to f of theta, even function. F of minus x equal to f of x, even function I can say. At the same time, when I'm talking about this one odd function, when I'm coming to odd function definition I can see, when they're talking about odd function, you can write f of minus x is equal to minus f of x. F of minus x equal to minus f of x, that function is known as odd function. When they define, here I can write f of, otherwise f of minus theta equal to minus f of theta, I can say that is odd function. Always I can represent function is odd function, I can say this one. Even and odd function I can define. That way I can define even and odd function. These four are odd functions. So cos and sec are even functions, that you remember. Now, after that, after completing this even and odd function, then I will discuss about, just I will give you an idea how to find 90 plus theta, 90 minus 0 combinations. When before I discussing about what is 90 plus theta, just you can think about the angles of combination. You can think 90 degrees plus or minus theta. Always we'll see this type of angles. 270 degrees plus or minus theta. That means here odd multiple 1 into 90, 3 into 90, odd multiple of 90. These combinations we will observe. In this case, remember, change will be there in the function. How the change will be, I can explain clearly also, but this is enough. How the change, sine will convert to cos, cos to sine. So tan to cot, cot to tan. Secant to cosec, cosecant, secant. The change will be there like this. If we see the problem, 90 combination or 270 combination, definitely right hand side, you can expect in the place of sine cos, cos of sine, sine of something. Right side, cos of. If you take cos of something, sine you can expect. So same thing, tan, if the tan of something, definitely right side you should get cot of something. So same, secant of, cosecant of. Just you remember this point here. Suppose if you take combination of 180 degrees plus or minus theta and 360 degrees plus or minus theta. So this is even multiple of 90, right? Even multiple of 90, 2 into 90, 3 you get 4 into 90, even multiple of 90. When you're talking about even multiple of 90, here there is no change. The same function will come. You can think no change I can write. In the trigonometric function, no change. So no change means sine to sine, cos to cos. Same thing will come. Tan to tan. And you can remember cot to cot. Secant to secant. And cosecant to cosecant. Right, there is no change. If you take any function, there is no change. Right hand side, the same function will repeat. In the case of combination of 180 degrees plus theta and 270, 360 plus or minus theta, 180 degrees plus or minus theta, no change in the given function. Same function will occur. But here, the change will be like this. So, whenever odd multiple of 90, the change will occur like this, you remember. So, I explained the position of these quadrants, I explained. Now, if we know that, we can find any trigonometric function value easily. I can express that. Now, I am going to explain. I can explain easily that value I can write. What I can write, you can see now, after learning this, after conversion, once if you learn the conversion here, then you remember this. Then I can express just no change, you can remember. Quickly I will do that. After that I will solve the problems. So it takes another half an hour. I will solve the problem, different types of problems I will explain after learning this one. See here, then I have taken this one. For example, 0 here. I have taken this is a like 90 degrees, 180 degrees, 270 degrees, and this is 360 degrees. Just you remember here. When I am talking 90 minus theta, what about these values of all six trigonometric functions? Just I am giving a brief about this. So sine of 90 degrees minus theta you want. How to find this value? Just a given table for you. When 90 is the change will be there. In the case of sine, cos will come. So it will be cos theta. But with the plus or minus I should write. This is house of everyone. House of everyone means definitely the value should be positive here. Here plus or minus depends upon left hand side function. It never decide right hand side function. The value is positive or negative. Decided will be only left hand side function. It will not be decided by right hand side function. Just you remember that in your mind. That is most important point. So you remember that one. Now here I have taken sine of 90 minus theta cos theta. Suppose if you write cos of 90 degrees minus theta. Just you remember the previous table. If you remember the previous what I suggested you 90 minus first quadrant. So all are positive. For 90 change will be there. For 90 cos means sin theta it will come. Because I have told for combination of 90 or 270 change will be there. So I suggest you that change will be there. Cos 90 minus theta sin theta will come. Sin 90 minus theta cos theta will come. Now similarly, if we take tan of 90 degrees minus theta, same thing it will come cot theta. Positive will come positive. The remaining 3 also you can think similar to this. Similar to this you can think, I explained only 90 minus theta. Everything you can explain. If you take suppose cosecant, you will get sec. If you take cot 90 minus theta, you will get tan theta. Sec 90 minus theta, you will get cosecant 90 minus theta. All 6 you can find like this. For 90 minus a change will occur like this. Suppose if you think 90 plus theta, 90 plus theta will come here. You can see, just I'm giving an idea. How to do 90 plus theta, how to find the 90 plus theta value. When I'm talking about sine of 90 plus theta. So first you check 90 plus theta second quadrant. Second is house of sine and cos. This is house of sine and cos. This is house of everyone. This is house of tan and cot. This is house of cos and sec. You remember that point. When I enter 90 plus theta, it is house of sine. So it's a positive only. Yes, positive. Because house of sine only. For 90 change will be there. Cos will come. Cos theta will answer. Sine of 90 plus theta will be cos theta, it will come. Sine of 90 plus theta. Now if you take cos of 90 degrees plus theta. If you take cos of 90 degrees plus theta, think about cos of 90 degrees plus theta. So again you can see 90 plus theta second quadrant, but this is not house of cos. Here plus or minus will be decided by this function. So cos is a negative in second quadrant. This is house of sine and cosec. So minus. So for change will be there, it will come sine theta. So you will get minus sine theta. Similarly, if I think here, okay, now you can see here what I am saying now. Here cos of 90 plus theta is minus sine theta. Now here I am saying here, suppose tan of 90 degrees plus theta. Suppose if you take tan of 90 degrees plus theta, 90 plus theta again second quadrant, house of only sine and cosec. So tan will be negative. This is not house of tan. So they should request permission, right? It will be minus, you will get minus cot theta. So you will get minus cot theta. The remaining three also you can discuss about like this in the case of here. 90 degrees plus theta, I'm talking about that. Suppose we come here. So again I can also discuss 180 degrees minus theta because this is 180. Even 180 minus theta I can consider here. Whenever I'm talking about 180 minus theta, you can think about sine of 180 degrees minus theta, second quadrant, position of this angle, second quadrant, but there is no change for 180 degrees. Before that, in second quadrant, this is house of sine only, positive, 180 no change, then I can write sine theta, one I can write, then I can write sine theta, even I can write cos of 180 degrees minus theta. So if you take cos of 180 minus theta, this is not house of, I told you this is not house of, and this is cos, so it will be minus 180 no change, you will come minus cos theta. Similarly, putting tan of 180 degrees minus theta, so this is not house of tan, so minus 180 no change and minus tan theta. Even the remaining 6 you can think of, remaining 3 also you can think about like that. Now coming to here, this will become 180 degrees plus theta and 270 degrees minus theta. These are the position of this angle. Here it will come 180 degrees plus theta, 270 minus theta. So if we come here, we can think about these angles. If we think here, the position of the angles, if you work out here, the position of the angle is correct. This is 180 degrees, right? When I'm talking, this is 180 degrees. Now you can observe here, when I'm talking this one, so I'm entering third quadrant. Suppose you want sine of 180 degrees plus theta. So when I'm talking sine of 180 plus theta, what about the position of this? When I'm talking sine of 180 plus theta, then you can see 180 plus theta is third quadrant. This is house of tan and cot. So 180 plus theta no change. It will come, but this is house of tan and cot. This is not house of sine. So minus 180 no change. The answer will be minus sine theta. So you take cos of 180 degrees plus theta. But if you take cos of 1 plus theta, again you first think 180 plus theta belongs to third quadrant. Third is house of tan and cot. Only tan and cot are positive. Remaining functions are negative in third quadrant, right? So cos will become minus. For 180 no change, you will get minus cos theta. Coming to now tan. If I take tan of 180 degrees, if I consider tan of 180 degrees plus theta. If I take tan of 180 degrees plus theta, now see, in this case, when I have taken tan of 180 degrees plus theta, again this is the function of same house only, so positive only, 180 no change, you will get a tan theta only, tan of 180 plus tan theta. We can think about remaining, even if I write cosecant of 180 degrees plus theta, no change. This is house of tan and cot, so cosec will be minus, so minus cosec theta. Even secant of 180 degrees plus theta, so this is not house of secant, so you'll get minus secant theta. Cot of 180 degrees plus theta, this is house of cot only, so positive, you'll get cot theta only. If they are entering their house, positive. See, tan and cot are positive. For 180 no change, same function I can write, I can replace same function. If the combination of 90 plus theta, 90 minus theta, change will occur. In the combination of 180 minus theta, 180 plus theta, no change. Now, if we are thinking about 270 minus theta, so think about 270 minus theta again. 270 minus theta belongs to which quadrant? That you can think. 270 minus theta belongs to, you can see here, thus 270 minus theta belongs to, this is the third quadrant, right? So the 270 minus theta belongs to third quadrant. You can think sine of 270 degrees minus theta. When I have taken sine of 270 degrees minus theta, this one you can observe here. When I have taken sine of 270 minus theta, the value you can observe here. What about sine of 270 minus theta? If you take this, first you check this is the house of tan and cot minus 270 change will be there. For sine you will get cos theta, right? Say cos of 270 degrees minus theta minus sine theta plus for 270 change will be there. This is house of tan and cot. Cos will become negative. So you will tan off. If you take tan of 270 degrees minus theta, so if you take tan of 270 degrees minus theta, in the case you can observe here, what will be this value? 270, when I have taken 270 degrees minus theta, same house, this will be positive, but 270 change will be there, you will get cot theta. You will get cot theta, right? Like that remaining other three, I can define here in the case of 270 minus theta. If we come here, you will get 270 degrees plus theta, and this will come 360 degrees minus, you will get minus theta, and here 360 degrees plus theta. Plus theta. Now we understood here. Randomly I will express. Suppose you plus. If you take plus, what about this value? If it is plus, you entered in fourth quadrant. In fourth quadrant, 270 change will be there. In fourth quadrant, sign is negative. This is okay. Because in fourth quadrant, sign is negative, minus change will be there cos theta. Cos of 270 plus theta. When I have taken cos of 270 plus theta, you can think now. When I am talking about cos of 270 plus theta, when I have taken this, you will get now observe here. When I 270 plus theta, you get here this house of cos only, it will be positive. Because house of cos. Tan of 270 plus theta. This is fourth quadrant, house of cos and sec, so it will be minus cot theta. You get minus cot theta. Remaining three I can discuss like this. Now, if we come into 360 minus theta, so I will discuss with 360 minus theta. I will get prepared about that. Then I can explain the problems. So if I take 360 degrees minus theta, suppose if I take sine of 360 degrees minus theta. When I have taken sine of 360 degrees minus theta, now you can observe here, sine of 360 degrees minus theta I have taken. So this is fourth quadrant, sine will be negative, but 360 no change, you get minus sine theta. Cos of 360 degrees minus theta if we consider, cos of 360 degrees minus theta, you can observe here. When I have taken 360 minus theta, this is again fourth quadrant, house of cos only, it becomes positive, 360 no change, it will come cos theta. Now, the same time, tan of 360 degrees, we can take it minus theta, it will come minus tan theta, because this house of cos and sec, tan will be negative. If these are the three things, right? Similarly, other three can think. Suppose if it is plus, if we enter first quadrant, all are positive, no change, all are positive, we can make it. This will be positive. So right side plus or minus depends upon the left hand side function. It never decided by right hand side function. First you check the angle where it is. Check the angle position. So when the angle is first, all are positive. When the angle is second quadrant, sine and cosec are positive, other are negative. When angle is third, only tan and cot are positive. Value of tan and cot positive, other values are negative. When it is fourth quadrant, cos and sec are positive, other functions are negative. That you should remember always. That is most important point. You can remember those things here. After that, just we can find the trigonometric values. Then I can solve the problem quickly. I can tell the important models I can discuss now. So these are the main maximum what I explained here. Now I am explaining here, for example, you take 0 degrees, 30 degrees, 45 degrees, they are taking about 60 degrees, 90 degrees, they are talking about this one. You can see here I am talking about these values. So sine, cos, tan, these three enough, right? Sine, cos, tan. This is 0. This is I can write pi by 6, pi by 4. This I can write pi by 3, pi by 2, 90. So this is pi by 2, right? Pi by 2 I can write. Even I can write 180 degrees, 270 degrees, 360. I can write these values also. 180. This is pi. You can write 3 pi by 2. This is 2 pi. Right? These are the values, right? These are the values in radians. So to remember, they define here the values sin 0, 0, 1 by 2, 1 by root 2, root 3 by 2, 1, sin 180, 0. For every value of sin, every multiple of n by 0, sin 270 minus 1 times 360, 0, 2 pi. It will be 0 here. So now you can see cos value. If it is cos 0 is 1. Cos 30 root 3 by 2. I can define this. 1 by root 2. I can define this one. Cos 60, 1 by 2. Reverse this one. You will get cos 90, 0. Cos 180 minus 1. Remember, cos 270, 0 here, right? Cos 360, it will be 1. Co-terminal angle. 0 and 360, co-terminal angles. I can coincide with the tan value. What is tan sine by cos? When I'm talking about sine by cos, 0 by 1. So if we take 0 by 1, 0, 1, right? This by this, you will get 1 by root 3. So this by this 1 and 40 by 1, you will get root 3. So 1 by 0 is not defined. Or I can say infinity, or I can say not defined. Not defined. 0 by minus 1, 0. Again not defined. Minus 1 by 0. And you can say get 0 by 1. Again at 0 here. This is the values of this. Just remember these values. Now I am going to explain the problems of 3.2 exercise. Only 2-3 models. I will explain those problems. Then I will do the next exercise important problems. Now coming to here. First one you can see here. Find the value of sine 765 degrees. How to find the value of sine 765 degrees? Sine 765 degrees. Think how to find that value sine 765 degrees. I can write sine of, see the number of rotations, 2 into 360 degrees, 720 plus 45. I discussed previously co-terminal angle. So this is co-terminal to 45 degrees. Otherwise, if you are not remembered co-terminal, just remember 360 plus theta, which quadrant? This is number 2 is the number of rotations. 360 plus theta, first quadrant. You entered in first quadrant. All functions are positive. All trigonometric functions are positive. There is no change in the value. The value of symbol of sine is a positive one. All are positive, and 360 no change in the function. You will get sine 45 degrees. So answer is 1 by root 2. Sine 765 degrees is 1 by root 2. This is one of the problem I've done here. Another one I can think about cosecant of minus 1410 degrees. So you think this is the problem here. But here you can think, what is cosec of minus theta? Minus cosec theta. Cosecant of minus theta minus cosec theta minus cosec 1410 degrees. You can think how many rotations are there in this. You can think about how many rotations are this. I can write minus of cosecant of. You can think about this one. How many complete rotations are there? If I think about the rotations here, automatically you will get that value. I can think about, suppose you write 360 into 3, you will get, you can see here 1180. So you can see here, and I have written here. So total 3 rotations means, so you can see here. So 1080, this one 1080, right? I can, how much I should add here for this one, you can see. Or I can add into 4 rows, I can write. Even 4 rows I can write. If you write this is 1080, right? You can see the difference of this. Check the number of rotations. So 1080. If you take 1410, 1080 with this one, you can see here, you will get 3, and you will get 3 right here. You will get 330 degrees. So complete rotations 3 are there. I can write 3 into 360 degrees plus 330 degrees. So I won't do like this. I will write 4 into 360 minus. That is also right. You can go ahead that way also. Here I have taken number of rotations. I have taken here. I have written 3 into 360 plus 330. Now you think only in our mind 360 plus theta, which quadrant? First quadrant, all are positive. 360 no change. I can write minus cosec 330 degrees. Minus cosec 330 degrees. This minus cosec 330, I can also write minus cosec. Now you write 330 degrees. 360 minus 30. The known angle. I have taken 360 minus 30, right? 360 minus theta belongs to fourth quadrant. 360 fourth quadrant. In fourth is also cos and sec. Cosec will be negative. So minus of minus 360 no change. It will be cosec 30 degrees. Right? Minus minus positive. Cosec 30 degrees it will come. So sine we know, sine 30 is 1 by 2, cosec 30 is 2. Your answer is 2. Like that I can find the value of that. That way I can find the value of that. Another one, they are given tan 19 pi by 3. Find the value of tan 19 pi by 3. So when they are asking tan 19 pi by 3, you think how to find the tan 19 pi by 3. So when I am trying to find tan 19 pi by 3, see the value of tan 19 pi by 3. Tan 19 pi by 3. Check that how many rotations are there. First you can see this is tan of, I can write 6 pi plus pi by 3, can I write? 6 pi plus pi by 3. It can be written as 6 pi plus pi by 3. Of writing this, you can say I written 6 pi plus pi by 3. So when I have written like this is tan of, so you can observe your tan of, what is this one? 2 into 3 pi. Again, rather you write 3 into 2 pi, number of rotations. 3 into 2 pi plus pi by 3, you can write like this. 3 into 2 pi plus pi, 2 pi plus theta. 2 pi plus theta belongs which quadrant? You can observe here. 2 pi plus theta, first quadrant. If you think first quadrant, I can write this is first quadrant, all are positive. It will 2 pi no change, it will come tan pi by 3. So it will come tan 60, root 3 will come, answer is root 3 will come. Tan 60 is root 3. I can find the value like this, tan 19 pi by 3. Next they are given sine of minus 11 pi by 3. Sine of minus 11 pi by 3. Sine of minus 11 pi by 3. You think about this value. Well, how to do this one? But we know that sine of minus theta is minus sine theta. Sine of minus theta is minus sine theta. It will be minus 11 pi by 3. Minus pi by 3. Sine of minus 11 pi by 3. You will get like this, right? Now we can observe here. When I have written like this, minus 11 pi by 3, how many rotations are there here? I can write better to even number you prefer. Even number of pi will come. It completes the rotations. So I can write this is a 2 pi. I can write this is a, see you get pi by, I can 5 pi by 3 I can write, right? So you can see here 3 to 6 plus 5, 11 pi by 3, 2 pi plus 5 by 3. 2 pi plus theta, again coterminal angle. So first quadrant, all are positive. 2 pi no change, minus sine of 5 pi by 3. Correct? You get 5 sine of 5 pi by 3 will come. You can serve this angle, you can see whatever this angle here. You can here you can write pi plus, you can simplify here. This one you can simplify. Pi plus 2 pi by 3, I can simplify. This one I can simplify. Minus sine of pi plus 2 pi by 3, I can simplify this through 3 pi plus 2 pi. Now you can think of writing this 180 plus theta. 180 plus theta belongs which quadrant? 180 plus theta belongs to third quadrant. Third is the house of tan and cot. Sine will be negative. I can write minus sine 2 pi by 3. I can write, right? It will become minus of minus plus. It will be sine 2 pi by 3. So you can see here sine 120 here. I can write understood pi plus 2 pi by 3. You got a sine of 5 by 3. I got like this. You can see 3 pi plus 2 pi 5 by 3. I got. So what I have done? Sine 180 plus theta. When I have taken sine 180 plus theta, third quadrant, sine will be negative minus 2 pi by 3. It will be sine 2 pi by 3. So this value you can write. So still if you want to see, you can simplify this. This is the sine you can see here. This is you will get the value of this 120 degrees. You will get that. I can simplify this value. So you understood this way I can simplify. Or directly also you can simplify. 4 pi minus also you can simplify. 4 pi minus 4 pi. Sir, why you are taking this much? Can I simplify 4 pi by minus 3? So you are getting this is lengthy. I can make it like this also. Suppose we make it this one. So instead of that, can I make it? Yes, we can do like this. Minus of sine 4 pi minus pi by 3. I can simplify. I can write like this. This is a simple. Compare the previous one. This will be simple. 12 pi minus pi 11 pi by 3. So I can write minus sine of. So previous one it will be complicated if you think. I can write like this, right? This is 2 into 2 pi, 4 pi, 2 into 2 pi minus pi by 3. 2 pi minus pi by 3 belongs which quadrant? 2 pi minus pi by 3 belongs to fourth quadrant. It's correct. This fourth quadrant, fourth is sign is negative. So minus sine pi by 3 I can write. So this is simple. You get sine pi by 3. So the value will become correct. So you can see here I have written like this. Against minus 7 pi by 3. Again minus of minus plus 7 pi by 3. So what is the value? It will come this will come sine pi by 3 will be sine, you will get sine 60, right? You will get root 3 by 2. That value comes sine 60 root 3 by 2. The value will come root 3 by 2. Now after that, so these are the problems we completed here. So the one more problem is there here. Cot of minus 15 pi by 4. Cot of minus 15 pi by 4. Cot of minus 15 pi by 4. So this is the problem. Cot of minus theta. It will be minus cot theta. I can write minus cot 15 pi by 4. See the number of rotations here. So 15 pi by 4 means I can write 4 pi minus pi by 4. I can write 16 minus pi. I can write. So minus cot 2 into 2 pi minus pi by 4. Correct? So similarly like this 4 pi minus pi by 4. 2 pi minus pi by 4. 2 pi minus theta I have taken. So minus cot of, I can write this one. 2 pi minus pi by 4 belongs to fourth quadrant. Cot will be negative. For 2 pi no change. Minus cot pi by 4 I can write. So minus, say I can write this one. I have written directly here. Minus, we can write minus of z. I'm talking about this one. Minus cot pi by 4 I can write. 2 plus 2 pi minus theta fourth quadrant. Cot will be negative. So cot pi by 4. So finally your answer is 1. Cot 45 is 1. So these are the problems I explained here. Now in the first two, problem number in 3.2, 1 to 5. For two problems I will explain. I can complete 3.2 exercise. So I can complete that. This is the problem here. Now, when I am doing, if you need doubt, you can send me in the chat box information. I can explain. Again, I can explain here. So if you want, I can explain here. So if you have doubt, you can ask me, I can explain. For example, you see the first problem. Cos x is equal to minus 1 by 2. Cos x is equal to minus 1 by 2. X lies in third quadrant. They are saying here, x belongs to third quadrant. Find the remaining trigonometric functions. Find the values of remaining trigonometric functions. So to find the remaining trigonometric functions, when they are asking to find the remaining trigonometric functions, first you think this is third quadrant. Third is house of tan and cot. Only tan and cot are positive. Remaining functions are negative. Suppose you take this is x here. So you will get this is 1 and this is 2 because they are given 1, 2. And what about the other side? You know the Pythagoras theorem here, right? So apply Pythagoras theorem, you can find this one. So AB square equal to, I can write AC square minus BC square. You will get 4 minus 1. 3AB is root 3. So this is root 3, right? After knowing this value, you can find this. Now you write cos x is minus 1 by 2. Secant x is minus 2, reciprocal. Third is secant also negative. What about sin x? Opposite side by, you get root 3 by 2. So in third quadrant, sin is negative, minus root 3 by 2. Even cosecant x reciprocal of this, minus 2 by root 3, right? Reciprocal of that. When I have taken this reciprocal, even if you take tan x. So tan x belongs to third quadrant only, root 3 by 2. Even cot x positive, 2 by root 3. Why these two are positive? The reason why these two are positive, so the reason here, this is belongs to third quadrant. Third is also of tan and cot. There's the reason these two are positive. So remaining functions are negative right here. So you can think about remaining functions are negative. So only tan and cot x are positive. Remaining functions are negative. That you can remember here, right? So that way you can remember this one. That point you can remember. In this way you can remember. Now here after finding this value, I can also define the value of, you can see here, these are the values I defined here. Now I can define completing these values. So like this all functions I can define. Now you can think about similarly, I can explain one more problem in this because most of the problems similar to that. You can solve those problems. So just I will explain one more problem here. So you can write, you can consider tan x is equal to minus 5 by 12. They are given tan x is equal to minus 5 by 12. When tan x is equal to minus 5 by 12, they have taken tan x is equal to minus 5 by 12. So tan x is equal to minus 5 by 12. X belongs to in second quadrant. So immediately you remember in second quadrant, house of sine and cosec, only those two are positive, remaining functions are negative. When I have taken minus 5 by 12, you can think this is x I have taken. So this is 5, 12. So this I have to find this one ABC. You know AC square. AC square equal to AB square plus BC square. I can write 144 plus 25 to the total you will get 169. This will be 13 square. So this will be 13, right? You will get 13. So I can write sin x. What is sin x? Opposite side by this one I can write 5 by I can write 13. So second quadrant sign is positive. Even cosecant x, I take reciprocal of this 13 by 5, it is positive. Cos x, yes, this BC by AC, it's inside hypotenuse 12 by 13. But in second quadrant, cos is negative, minus, even secant x, minus 13 by 12. If you take cot x, when I've taken cot x, so you think about when I've taken cot x with the reciprocal of this, minus 12 by 5. Like this I can find. So you can solve the problems like this. Similarly, you can solve in 3.2. If you want any problem with 3.2, you can ask me, I can come back, I can explain that. Now, after that, I'm going to explain the problems of like related to 3.3. Before doing 3.3, so you should know some formula also. I will solve few problems of 3.3, then I will come back to a little formula of trigonometric function, then I will solve that. So you can see here in 3.2, 3.3, the exercise 3.3, see the first problem. Prove that, I'm talking 3.3. So when I'm talking about 3.3, so the exercise 3.3. So I'm talking about 3.3. In 3.3, say prove that sin square pi by 6, prove that sin square pi by 6 plus cos square pi by 3, cos square pi by 3 minus tan square pi by 4, minus tan square pi by 4, which is good minus 1 by 2. So this is the problem they are given here. So you can see sin square pi by 6, cos square pi by 3 minus tan square pi by 4 is good minus 1 by 2. They are asking prove this. If you know the values, you can solve directly. They are asking this problem frequently. This type of problem they are asking. If you take LHS, so sin square pi by 6, sin pi by 6. What is the value of sin 30 degrees? 1 by 2 whole square. So cos pi by 3, cos 60, 1 by 2 whole square. Tan 45 is 1 square. So this will become 1 by 4, 1 by 4 minus 1. So you will take it 4 here, 1 plus 1 minus 4. You will get minus 2 by 4 minus 1 by 2. Your answer is minus 1 by 2, right? You will get, that is your answer, minus 1 by 2. We got it here. So this is the first problem. If we go to the second problem, prove that 2 sin square pi by 6, prove that 2 sin square pi by 6, 2 sin square pi by 6 plus cosecant square 7 pi by 6, cosecant square 7 pi by 6, they given into cos square pi by 3, cos square pi by 3, which is equal to 3 by 2, they are asking, which is equal to 3 by 2, they are asking here, 3 by 2. The value they pay 3, but they are asking, we will check here, the plus or product we will check. If you take LHS, 2 into sin pi by 6, 1 by 2 whole square. Cosecant square, you can see cosecant 7 pi by 6. You can think about this value. So how to simplify cosecant? You can observe here. So I want cosecant 7 pi by 6. So cosecant I can write here pi plus pi by 6, right? Pi plus pi by 7 pi by 6. 180 plus theta. Which coordinate pi plus theta? Pi plus theta belongs, you can think, pi plus theta belongs to third quadrant. Third is also of tan and cot. Cosec will be negative, minus 180, no change. You will get cosecant pi by 6. So minus cosec sin pi by 6 is 1 by 2. Cosec pi by 6 will be 2 minus 2. This one will be minus 2 whole square. Minus whole square. Into cos pi by 3, cos 60, 1 by 2 whole square. You can check this is 2 into 1 by 4. This will come 4 into 1 by 4. So you will get 2, you can cancel here, 1 by 2 plus 1, you will get 3 by 2. So that is the required result. We got 3 by 2, correct? Answer is 3 by 2. We got the required result. 3 by 2 we got it. So we can do like this. I have done and prove that in the this is the second problem. Similarly, you can also try the problems Similarly, you can also try the problems here. Other problems also I can help you to try this. You can think about similarly to try these problems. Like you can see the third problem, cot square pi by 6. So cot square pi by 6, cot square pi by 6 plus cosecant pi by 6, cot square pi by 6 plus cosecant square 5 pi by 6. So not square, only cosec pi by 6. Cosec pi by 6 plus 3 tan square pi by 6 plus 3 tan square pi by 6, which is equal to 6. They are asking to prove that value is equal to 6. The result will be 6. They are asking to prove the result will be 6. So when they are asking the result is 6, same you can how to prove this. So how to prove that value? So when I am talking about to prove that value, just again you substitute the values here. I can substitute the values here. If you take this one LHS, so this is direct. After that I can solve the next problem. You can see this is LHS. I can take it cot pi by 6. So cot 30 degrees. So cot 30 is, you can write root 3 whole square. Cosec 5 pi by 6. You can see what about the cosec 5 pi by 6? You can think about cosec 5 pi by 6. This value I can think this is pi minus pi by 6. Correct? Pi by 6. Pi minus pi by 6 belongs to second quadrant, house of sine only. It will be cosecant pi by 6. Correct? Cosec pi by 6. You will get the value is 2. So this will be 2 plus 3 into tan pi by 6, tan 30. So you can tan pi by 6 nothing but tan 30 degrees, right? Tan 30 is 1 by root 3. You will get 1 by root 3 whole square. You can simplify this. This will be 3 plus 2 plus 3 into 1 by 3. So we'll get 5 plus 1, it will be 6. We'll get RHS. Similarly, you can try other problem. After that, now fourth one, you can similarly do that. Now I'm going to do that. Find the value of sine 75 degrees. Find the value of sine 75 degrees. Find the value of sine 75 degrees. How to find sine 75 degrees? So when I'm taking sine 75, sine of I can write 30 plus 45, right? Take 30 plus 45. If I expand 30 plus 45, this will become sine 30 degrees cos 45 degrees, cos 30 degrees sine 45 degrees, right? Now you can think sine 30 1 by 2, cos 45 value 1 by root 2, and cos 30 you will get root 3 by 2. Correct? You can think about this one. Sine 45 1 by root 2, you will get 1 plus root 3 by 2 root 2. So like this you can find sine 75 degrees. I can find sine 75 like this. Next they are asking tan 15 degrees. When they are talking tan 15 degrees, you can observe here. When they are talking tan 15 degrees, I can write tan 15 degrees means you can write 60 minus 45 or 45 minus 30. Even you can prefer anything. When they are talking tan, you can see the value of tan 15 degrees. When they are asking tan 15, I can write tan of 60 minus 45 or 45 minus 30. Anything I can consider. So you write tan of a minus b. So you can apply tan of a minus b here. What is tan of a minus b? So tan 60 degrees minus tan 45 degrees by, I can get 1 plus tan 60 degrees tan 45 degrees, right? Because you know the formula, you should apply here. Tan 60 value, tan 60 is here root 3, tan 45 is 1. I can write this by here 1 plus, I can get tan 60 root 3 into tan 45 1. You get root 3 minus root 3 plus 1. So I can rationalize this. I can rationalize with, you can see root 3 minus 1 by root 3 minus 1. I can rationalize this. The value I can rationalize. If I rationalize that value, just I can rationalize this. If I rationalize, you can see root 3 minus 1 whole square by, you will get a plus with a minus b, root 3 whole square minus 1 square, right? So a square plus, you can expand this, you will get 3 plus 1 minus 2 root 3 by, you will get 3 minus 1. So you will get 4 minus 2 root 3 by 2. So you can simplify this, you'll get 2 minus root 3. So this is the value of tan 15 degrees. You can find the value of tan 15 degrees is 2 minus root 3. I got that value. Next, we are talking about like sixth problem. Prove the following. See the sixth problem. When I'm talking about sixth problem, prove the following. So when they are asking prove the following, the sixth problem in 3.3 exercise. In 3 point, this is because your preparation you can practice now itself. You can observe here. When I have taken this problem, prove that cos pi by 4 minus x, cos pi by 4 minus x, cos pi by 4 minus y, cos pi by 4 minus y, minus sine of pi by 4 minus x into sine of pi by 4 minus y, sine of pi by 4 minus y, which is equal to, they are asking sine of x plus y, which is equal to sine of x plus y. They are asking to prove that the result will be equal to sine of x plus y. Now you can think it's a cos A cos B minus sin A sin B. Let it be this is A. You can think. So you can consider this is B. Same thing, this is A. Correct? This is the B you can consider. So it will be cos A cos B minus sin A sin B. Then I can write LHS, I can write cos A cos B minus sin A sin B cos of A plus B. So pi by 4 minus x, pi by 4 minus I will come. Cos A cos B minus sin A sin B is cos of A plus B. So cos of pi by 4 plus pi by 4, pi by 2 minus of x plus y. Cos 90 minus theta belongs to first quadrant. Cos 90 belongs to first quadrant. All are positive here. Cos 90 minus theta belongs to first quadrant. Here all are positive, right? All else are positive. For 90 change will be there. It will come sin of x plus y. Your answer is sin of x plus y. So that will be your answer, sin of x plus y. Next one, tan of pi by 4 plus x by tan of pi by 4 minus x. So tan of pi by 4 plus x by tan of pi by 4 minus x. Think about other next problem I'm talking. Tan of pi by 4 plus x, tan of pi by 4 plus x by tan of pi by 4 minus x. So which is equal to 1 plus tan x by 1 minus tan x whole square. This is the problem, right? So they are asking about how to solve this problem. So when they are talking about this problem, you can observe here. In this problem, the main important thing here, this mainly in this problem, tan 45 plus x. You think about tan of, you can take it LHS. I can write tan of A plus B. I can get tan pi by 4 plus tan x by 1 minus tan pi by 4 tan x. I have written tan of A plus B, right? I expanded here by same thing, tan of A minus B, tan pi by 4 minus tan x by 1 plus tan pi by 4 tan x. I can write there. I just have written. You know here this one tan pi by 4 1 plus tan x by this is 1 minus tan x. Why? Because tan 45 is 1. Here similarly I can write 1 minus tan x by 1 plus tan x, right? I have the denominator fraction converted. This is a quotient converted into multiplication. I can write this one 1 plus tan x by 1 minus tan x into 1 plus tan x by 1 minus tan x. Correct. We can think 1 minus tan x. Just you think about this is tan x here. So you can see the required one you will get 1 plus tan x by 1 minus tan x whole square, right? So that is the required one. This is the problem number. I have done 7th one. Now coming to the 8th one also, most important one, 8th one also. So generally you can see in the PO also sometimes they are asking 8th one, frequently they are asking 8th one also. We'll look at the 8th problem. If we come to the 8th problem, so just you can compare with the 8th problem. So when I'm talking about 8th problem, so what will be the 8th problem here? The 8th problem is cos pi plus x. Think cos of pi plus x, cos of pi plus x into cos of minus x by that will be about sine of pi minus x, sine of pi minus x into cos of pi by 2 plus x, cos of pi by 2 plus x, which is equal to they're asking cot square x, they're asking to prove cot square x. This is equal to cot square x. You think to solve this problem, just get an idea about that. You will think how to apply here, how to simplify. Just think about that, how to simplify that. You think how to simplify that one. Just you remember cos of pi, you take LHS. Cos of pi plus cos of 180 plus x. So this is the third quadrant. Third is also of tan and cot. Cos will be negative, right? This will become minus 180, no change, minus cos x. Cos of minus x, you know cos of minus theta, cos theta. This will become cos x by sin of 180 minus x, second quadrant. Also of sin only, it will be positive. It will be sin x, 180, no change. Pi by 2 plus x comes to second quadrant. Second is also of sin and cosec. Cos will be negative, minus, for 90 change will be there, you'll get minus sin x. So you can see minus ones cancel again, this will become cos square x by sin square x. Again eliminate minus, this will become here cot square x. This is a simple problem. The result will be cot square x. You will get the answer is cot square x. Now, we can think about the next problem. So when I'm talking about here, see the ninth problem. So next the ninth problem, cos of 3 pi by 2 plus x. Cos of 3 pi by 2 plus x. Cos of 3 pi by 2 plus x into cos of 2 pi plus x. Cos of 3 pi by 2 plus x. Cos of 3 pi by 2 plus x into cos of 2 pi plus x. Cos of 2 pi plus x into cos of 3 pi by 2 minus x. 3 pi by 2 minus x. Cos of 3 pi by 2 minus x plus cot of 2 pi plus x. Cot of 2 pi plus x, which is equal to minus 1. They are asking. Prove that is equal to 1. This is equal to 1. They are asking. Prove that that value should be 1. They are asking that value is equal to 1. When they are asking that value is equal to 1, you can observe here. Now if I take LHS again. So cos 3 pi by 2 plus x. 3 pi by 2 plus x belongs to, you can think, fourth quadrant. So house of cos only. 3 pi by 2 can expect change. It will come sin x, right? 3 pi plus x in fourth quadrant. House of cos only. 3 pi by 2 cos will become sin x. Now cos 2 pi plus x comes to first quadrant. All are positive. No change. This will become cos x. Correct. Coming to here. Cos 3 pi by 2 minus x. 3 pi by 2 minus x belongs to third quadrant. Third is also of tan and cot. Cos will be negative. Function will change. You will get minus sin x. Coming to here. Cos of 3 pi by 2 minus x, right? Sorry, this is not cos. They are given cot. I have done a mistake. This is given cot, this one. The problem is given cot. The given cot of 3 pi by 2 minus x, both are cot only. If we take 3 pi by 2 minus x, third quadrant, house of cot only. House of cot is positive only, but it will come tan x. This one. 2 pi plus x first quadrant. 2 pi no change. It will be cot x. It will come like this. Now I can write sin x into cos x. This is sin x by cos x plus cos x by sin x. Right? I can simplify now. Now I can simplify. If I simplify this, you can see sin x into cos x. It will become cos x into sin x. So this will become sin square x plus cos square x, right? Sin square x plus cos square x. Now here you can think about when I have taken this value is 1. So I can eliminate this, I can eliminate this. This is 1. Answer is 1. This is good because important one, this one. You can think about this one. You can solve this problem easily. You can solve this. Now I will explain the question number here. See this one, 10th one. 10th one I will explain. Sin of n plus 1. I think 10th one, there's a problem is simple. It's like sin A sin B plus cos A cos B. So cos of A minus B. I think you can apply that. Sin A sin B plus cos A cos B. Cos of A minus B. You can apply, can do that. Now coming to the 11th one. So you see the 11th problem, cos of 3 pi by 4 plus x. This is the 11th problem. When I have taken the 11th problem, cos of 3 pi by 4 plus x, 3 pi by 4 plus x, cos of 3 pi by 4 plus x, minus cos of 3 pi by 4 minus x, which is equal to minus root 2 sin x, minus root 2 sin x. See a very simple technique here. You remember cos of a plus b minus cos of a minus b. You remember the formula here. Cos of a plus b minus cos of a minus b. If you remember this formula, cos of a plus b minus cos of a minus b, you will get this is 2 cos a cos b. You will get this is the formula. This is plus. If I take plus here, 2 cos a cos b. If I take cos of a plus b minus cos of a minus b, this will be minus 2 sin a sin b, minus 2 sin a sin, that will be the formula, minus 2 sin a sin b. So you think second formula can apply here. If you take LHS, see this is the formula, you can see a plus b, a minus b. You have cos of a plus b, cos of a minus, you apply this formula for this, your answer is minus 2 sin. So what is a here? This is a, correct? This is a. You will get 2 sin a, 2 sin 3 pi by 4. Correct? You will get this is b. You will get sin x. Sin, this is sin 135. Minus, you can see sin 3 pi by 4. So 3 pi by 4 I can write sin of pi minus pi by 4. To the second quadrant. In second quadrant, always sign positive. Sign positive. 180 minus theta. It will be sin pi by 4. So sin pi by 4 is 1 by root 2. You get 2 into 1 by root 2 into sin x. Correct. You will get minus 2 by root 2 into sin x. If I simplify this with minus root 2 into sin x. So this is the problem, right? What I explained here, the question number 11. Before solving 12 and 13, I'll give a formula. If you know that formula, directly you can solve the problem. So directly you can solve the problem if you know that formula. What is that formula? Instead of plus and minus, I am going to talk about product. So what is sin of a plus b into sin of a minus b? Cos of a plus b into cos of a minus b. You should know that formula. If you remember, sin of a plus b into sin of a minus b equal to, just remember the formula, sin of a plus b into sin of a minus b. To take this, sin of a plus b, sin of a minus b. This formula is sin square a minus sin square b. Always. If we convert in terms of cos, this will be, I can write cos square b minus cos square a. Sin square a minus sin square or cos square b minus, remember cos square b minus cos square a. What about cos of a plus b into cos of a minus b? If we take this one, cos square a minus sin square b. See the previous one, both are sin, both are cos. Cos sin square a minus sin square b, cos square b minus cos square a. If we take cos of a plus b, cos of a minus b, cos square a minus sin square b, even it can be written as here, I can write this is a cos square b minus sin square a also I can write. This is also right here. Just keep it over, but this is the product of these two functions, right? Cos of a plus b into cos of a minus b. Now if we know these two formulae, we can solve the problem. See, we can solve this problem, we can solve it. The problem number you can write sin square 6x minus sin square 4x. You take that. Sin square 6x minus sin square 4x. You take this one. Sin square 6x minus sin square 4x. You can compare. This is a. You can compare here. So I can write this is a, this is a, this is b. We compare. Sin square a minus sin square b. Because they're asking that value. What the answer they're asking? Sin square 6x minus sin square 4x is equal to sin 2x into sin 10x. They're asking to prove. They're asking to prove that. If you remember that formula, you take LHS equal to, directly I can write sin of sin square a minus sin square b. It is like this. I can express like this. Sin of 6x plus 4x into sin of 6x minus 4x. It will become sin 10x sine 2x. Just I am comparing the formula this one. Sine square A minus sine square B, sine of A plus B into sine of A minus B. I can write sine 10x into sine 2x I can write. So this is the, similarly you can do the next problem, 13th problem, cos square 2x minus cos square 6x. Cos square 2x minus cos square 6x. See that problem, cos square 2x minus cos square, they are given 6x which is equal to this another problem. Cos square 2x minus cos square 6x is equal to sine 4x into sine 8x. So you can think similar to this. They are given like this, cos square 2x minus cos square 6x. Both are cos square. So you think cos square b minus cos square a. So you think this is b. So this is a. So you take LHS. But when I've written this is a. But you get sine of a plus b. Sine of this is a. You can write sine of 6x plus 2x into sine of 6x minus 2x. Thus it will become sine 8x into sine 4x. So same result it will come. Just this problem I can do using this formula only. So you remember that one. If you remember, I can do it. Okay. Then one more problem I will do that. One or two I will stop the class. Just I will complete now within one or two main problems. I will do that. Then again stop the class now. Now you can see here when I am doing this. So even you can send your doubts, individual also can send your doubts. I can explain. Yes, I am going to suggest another few more minutes. I will stop the class here. You think about to solve this problem. Prove that sine 5x plus sine 3x. Prove that sine 5x plus sine 3x by sine 5x plus sine 3x by cos 5x plus cos 3x, cos 5x, cos 3x, which is equal to tan 4x. Tan 4x. How to solve this type of problem? Just I will explain this one more. And the two problems I will explain. I will stop the class. You can see here when I give tan 4x. No, if you are patient here, we are able to listen means I can continue 4 or 5 problems. Otherwise, within another 2 problems, I can stop the class. You can send me in the chat box also. If you are ready to attend another 10-15 minutes, I can do more 3 to 4 problems. Otherwise, within 2 problems, I can stop. Let me discuss in the chat box also. That depends on your patience, right? Almost long by your sitting, you can decide. You can decide and let me know. So you can see when I've written here LHS. So sin C plus sin D. When I'm talking about sin C plus sin D, this will become 2 sin C plus D by to the formula sin C plus sin D. So 2 sin C plus D, but you remember here, what is sin C plus sin D? So you remember 2 sin C plus D by 2 into cos C minus D by 2. This is sin C plus sin D. So again I can use here, I have taken LHS, I can write 2 sin C plus D by 2, 5x plus 3x by 2 into cos 5x minus 3x by 2. I have done this. Correct. Just I have taken here by cos C plus cos D. What is cos C plus cos D? You can think about cos C plus cos D. 2 cos C plus D by 2 cos C minus D by 2. So this is a formula 2 cos C plus D. I can think about this one. I get 2 cos C plus D by 2 cos C minus D by 2. So when I have taken this, apply the same thing. I can write 2 cos, I can write 5x plus 3x by 2 into, I can write cos 5x minus 3x by 2. So same angle, I can eliminate this. 2 sine by cos tan. Angle is same, right? 5x plus 3x, 8x by 2, it will be 4x. The result will be tan 4x. Correct? Tan 4x. You got the answer? Tan 4x. So these are, you understood here, tan 4x. Can I continue another 10 minutes? Can I stop the class? Let me know, the people, you can decide about, can I continue the class another 10 minutes? Or can I stop the class? In the chat box, you can send me the information, just, you can let me know, you can discuss with my chat box. If you have patience, I can discuss in 10 minutes. Otherwise, anyone, the people who are attending the class, you can discuss with me, Sindhu or Priya. Yeah. Can I continue? I can continue. I can continue. Okay, fine. I can continue the class. So 10 minutes I can continue. So okay, now. What if I now you can see here. When I continue just a few minutes, I continue the class, you can see here the value of this I can write. Now, first think about this is the one of the problem here. Just sin x minus sin y. This is the same model like applying the same concept only. I can write another one on sin cos 4x plus cos 3x, cos 4x plus cos 3x plus cos 2x, cos 2x by, think about this one, cos 4x plus cos 3x plus cos 2x by sin 4x plus sin 3x plus sin 2x, which is equal to cot 3x. This answer cot 3x. So cot 3, this is also cot 3x. Now you can think they are given cot 3x. Now you can apply here. This cos you can see here. So you can think about any two I can combine. I can combine these two. I can combine these two to make it cos 3x comma y, because the right hand side we have cot 3x. I'm expecting cot 3x. So what I will do now? So I can take it combined here. LHS I can write cos 4x plus cos 2x by plus the remaining I can make it, this is one group, will be cos 3x. Same thing I can write sin 4x plus sin 2x. I can write plus sin 3x, right? It can be written as like this. I can write like this. Now, when I written like this, cos c plus cos d. When it is cos c plus cos d, I can write this one 2 cos c plus d by 2, 4x plus 2x by 2 into cos c minus d by 2, 4x minus 2x by 2 plus cos 3x by sin c plus sin d. When I have taken sin c plus sin d, you can write 2 sin 4x plus 3x by 2 into cos 4x minus, I can write 2x, I have taken 2x, 4x, so I have not here 4x plus 2x, right? So 4x minus 2x by 2, so plus sin 3x. Just apply the formula. If I apply the formula here, so the final answer should get cot 3x, right? Now here you remember the final answer is cot 3x is required. So if I continue here, this one, you can say this will become here 2 cos of 6x by 2 cos 3x, 2 cos 3x, cos 4x to 2 cos x, 4x minus 2x, 2x by 2 cos x plus cos 3x. So by, you can see here, this is 2 sin 3x, 2 sin 3x cos x plus sin 3x. So you take cos 3x common. If you take cos 3x common in the numerator, take cos 3x common, it will be 2 cos x plus 1. You take sin 3x common, it will be 2 cos x plus 1. Eliminate cos by sine, your answer is cot 3x. This model was important. Now after that, this is another important problem. Like they're asking this model. Like even one of the examples we have that type of problem. What is that problem? You can see here. Cot x, see cot x cot 2x. They're asking next cot x cot 2x. In this exercise, always the last problems are most important. So you can see in 3.3, the given cot x cot 2x minus cot 2x cot 3x minus cot 2x cot 3x minus cot 2x cot 3x minus cot 3x cot x equal to 1. They're asking to prove that result will be equal to 1. So here you can see, when they're given like this, to prove this, try to find relation among these three angles. I have x, 2x, 3x. You can write any relation among these three. I can create that. My choice, I can write x plus 2x is equal to 3x. You can write like this. Or you can write 3x minus 2x is equal to x. One of the relation, use these three angles, you can write. Apply cot on both sides. Apply cot on both the sides, apply cot. Cot of a plus b. You can write cot b cot a minus 1 by formula cot of A plus B, cot B plus cot A by 1 minus cot B cot A. Sorry, cot B cot A minus 1 by cot B plus cot A. You'll get like this, cot 3x. Just do the cross multiplication. This is a simple problem. Do the cross multiplication. You'll get cot 2x, cot x minus 1. You multiply this cot 2x into cot 3x and plus cot x into cot 3x. Right, because you see here minus terms are there. These two will transfer this side. You take minus 1 that side. That is the required answer. You can write cot x, cot x, cot 2x, cot x, this is the term cot x, cot 2x. If you take minus cot 2x, cot 3x minus cot x, cot 3x is equal to 1. That is the required answer here. So like this we completed the problem number 22. Now coming to the problem number 23. So another two problems if I do completely, I completed 3.3, almost we completed. So I think we'll be thorough with that. Now, correct here, it's clear, right? What is the next problem? Tan 4x. Think about this is the problem. Tan 4x is equal to the given. Prove that tan 4x is equal to 4 tan x into 1 minus tan square x. 4 tan x into 1 minus tan square x by 1 minus 6 tan square x. 1 minus 6 tan square x plus tan power 4x. Plus tan power 4x. This is the given problem. 4 tan x into 1 minus tan square x, 1 minus 6 tan square plus tan 4x. You can use combination of 2x plus 2x. You can use a combination, or I can use x plus 3x. Suppose you take tan 4x. You can use tan of x plus 3x. Tan of a plus b. I can write now tan x plus tan 3x by 1 minus tan x tan 3x. I can use. Now you can see here the tan x plus correct here, you write tan. What about tan 3x? 3 tan x minus tan cube x by 1 minus 3 tan square x. Just write the formula of tan 3x. Just write the formula of tan 3x. Now 1 minus tan x into 3 tan x minus tan cube x by 1 minus 3 tan square x. If I simplify this, I will get the required result, right? So they are asking tan 4x is that. So I can do here. Just if I simplify this, so tan x into this, you will get tan x minus 3 tan cube x plus 3 tan x plus 3 tan x minus tan cube x, right? By just taking LCM. So this is denominator 1 minus 3 tan square x by same thing I will get denominator here 1 minus 3 tan square x. Right, you get 1 minus 3 tan square x. When I'm taking this into this, you can see this is 1 minus 3 tan square x. You get minus 3 tan square x minus plus tan power 4x. I can write like this. I can eliminate these two. Correct? I can eliminate these two. After simplifying again, I can come back here. Just I can come back here. I can complete this. So here you can see here this will become. You can see here 3 tan x, 4 tan x. You will get 4 tan x minus 4 tan cube x. 4 tan cube x by. You will get. You can see 1 minus 4 tan. You will get 1 minus 3 minus 6 tan square x plus tan power 4x. Numerator, you can take it common here. You take 4 tan x common. You will get 1 minus tan square x, 1 minus tan square x by 1 minus tan square x by 1 minus 6 tan square x plus tan power 4x. So that is the required answer. Now another most important one, cos 4x is equal to. After this, one more problem is I can complete this. You can see almost 3.3 out and completely. You can see cos 4x is equal to. This is also one of the important problem. Most of the important they are given at the end only they are given. See cos 4x is equal to, prove that cos 4x is equal to 1 minus 8 sin square x into cos square x. I can take it RHS or I can take it LHS, anything I can use it. I can solve the problem. So if I take it RHS also, easily I can solve the problem. So 1 minus the given 8 sin square x cos square x is given here. 8 into, I can write this is 2 into, I can write 2 sin x cos x whole square, I can write plus 4 sin square cos square x. This will become 1 minus 2 into, this is sin 2x whole square. So 1 minus 2 sin square 2x. This is a formula. Why? Because 1 minus 2 sin square 2x always will be equal to cos 4x, right? Like that, right? This is equal to cos 4x. That will be equal to cos 4x. 1 minus 2 sin square 2x is cos 4x. Formula we know that. 1 minus 2 sin square theta. Because you remember here. Why? Because cos square, you can see here, cos 2x is equal to 1 minus 2 sin square x. This is the formula, we know that. Replace x with 2x, it will become cos 4x. Or 1 minus cos 2 theta, if you remember. This is 1 minus 2 sin square theta. Cos 2 theta, 1 minus 2 sin square theta. So this will become cos 4x directly. I can write easily. I can do that. Now the last problem. Cos 6x is equal to. So this will be the last problem. Cos 6x is equal to. When they have taken cos 6x is equal to 32 cos 4 6x. Cos 6x is equal to 32 cos power 6x minus 48 cos power 4x minus 48 cos power 4x plus 18 cos square x, 18 cos square x minus 1. This is one of the important problems. This also we can complete very quickly. I can complete this. So you can see here. When I have taken this one, cos 6x, 32 cos 4 6x minus 48 cos power 4x plus 18 cos square x minus 1. When I have taken this, you can say cos 6x. So you can think same way. I can, everything is in terms of cos. I can write cos 6, you can see cos 6x. I can get 2 cos square 3x minus 1. Because we know that, see what about cos 2x formula? You think cos 2x is equal to 2 cos square x minus 1. Correct. I can write this cos 6x. If you use this, I can write this one. You can see, if you ever convenient, 2 into 3x. So you can write 2 into the angle is 3x. If I write this will become 2 cos square. You can see 2x, 2 cos square x, 2 cos square 3x minus 1. I can write 2 into, what about cos 3x formula? Think about cos 3x formula, 4 cos cube x minus 3 cos x whole square minus 1, right? I have written here cos 3x is equal to 4 cos cube x minus 3 cos x, right? Formula you can think cos 3x is equal to 4 cos cube x minus 3 cos x minus 3 cos x. I have taken that formula. Just you can expand here, a minus b whole square, 2 into a square. Just expand a square 16 cos power, you will get 6x. I can expand again b square 9 cos square x minus 2ab 824 cos power 4x. Cos power 4x. Here I will get minus 1. Just I expanded with a square plus b square minus 2ab I have taken. And just say I have taken that formula cos power 4x. Now this will be 32 cos power 6x, 18 cos square x minus 48 cos power 4x. You can see minus 48 cos power 4x. I got 18 cos square x minus 1. You can compare this 32 cos power 6x. We got 18 cos square x minus 48 cos power 4x minus 1, which is equal to this is required 1 RHS. I got it. So like this I completed almost 3.3. Still if I need doubt, you can send me information. I can explain individually also. I can call you separately. I can explain individually also. So the patients you have listened to us almost. Oh, thank you everyone. Any doubt you have, please send me the message. I am ready to clarify. Any doubt related to this? Almost I completed. Along with you can prepare trigonometric equations. I can do any other class. I can do that. I can do that. So what is the 3.4? 3.4 is trigonometric equations, right? If you want, I can take the class around 7:30 to 8:30. If you are ready, I can take the class again 7:30 to 8:30. If you want trigonometric equations, who are interested, trigonometric equations, send me individual message. Then, if you wish to take, if you follow the class, at least I can take it 45 minutes between 7:30 to 8:30. I'm ready to take. If you are ready to attend trigonometric equations, you send me the message to me. You send me in the chat box also now. If you are ready, I will take the class. Or you send me individual messages. How many interested? I don't know whether 4 or 5 or 6. If you are interested, let me speak with me. I am ready to explain the 3.4 also. I am ready to explain. But exam, you should prepare everything. Okay, fine. See you. Interested, send me the message. Almost patiently. Some people are from the beginning they are attending. So thank you so much. We'll see you, meet you again after that. Okay, fine. Is it clear? Fine, thank you. If you like it, like this video, if you like it, you can continue that. But thank you. This okay? Fine.